All right, welcome back. Section 5.1. We're going to verify differential equations today. That word verifying should be something that comes into mind as we did in trig back in pre-calculus. Remember, we verified a trig identity where we made one side equal to the other by only working with one side of our equation. We're going to do the same thing with differential equations. So if we want to verify a differential equation, we want to work with only one side to make it look like the other. The difference that we're going to see is that they're going to give us something called a solution. So they're going to tell us something about the equation to start. So maybe y equals e to the negative x in our example here. We want to verify the differential equation. So we want to verify that 3y prime plus 4y equals e to the negative x. And the way we're going to do that is we're going to take that y equals e to the negative x, and we're going to go ahead and figure out what they want us to do with it. They want us to find y prime in that differential equation. So we know the derivative of e to the negative x is negative e to the negative x. So I can take that information and plug it in for my y prime. So I have 3 times negative e to the negative x plus 4 times my y, which I know y is e to the negative x, and I want that to equal e to the negative x. Again, I'm not messing with this right side, only with the left side. If I multiply my 3 through, I get negative 3e to the negative x plus 4e to the negative x, and a negative 3e to the negative x plus 4e to the negative x is a positive e to the negative x, which is what we want. So we have verified that differential equation. So that was an easy one. Now we're going to get a little more complicated as we get into this problem. And you'll notice I've got my work there covered up because I started working this problem and then my video stopped recording and I had to start it over again. So here we go. Maybe hopefully this one won't cancel out on me. So here's my differential equation. This is a fun problem. If I don't make a mistake on this one, then I don't know what I'm going to say about that. So y double prime plus 2y prime plus 2y equals 0 is the differential equation that we want to solve. And we know that y equals all of this. Notice in here we have a c1 and we have a c2. They could be the same constant, but they don't have to be. They could be different. So we have to be careful that that c1 stays c1 and the c2 stays c2. They will not cancel necessarily each other out. So the first thing I want to do is go ahead and find my y prime, since that's what we're looking for. So y prime here, well, c is a constant. We have e to the negative x times cosine of x, so we have that multiplication in there. It's going to be a product rule. So I'm going to write this as c sub 1 times e to the negative x, derivative of cosine of x, which is negative sine of x. And to that we're going to add the cosine of x times derivative of e to the negative x, which is negative e to the negative x. To that we're going to add the derivative of our second one. So again we have c2 and then derivative of e to the negative x sine of x. This gives us e to the negative x. Derivative of sine is cosine of x. To that we're going to add 2, which is sine of x, and then derivative of e to the negative x, which is negative e to the negative x. I can go ahead and clean this up. And in here, we can pull an e to the negative x out. So I have e to the negative x, c sub 1, times our negative sine of x minus a cosine of x. And then over here, my c sub 2, I can pull an e to the negative x out. And that leaves me with a cosine of x minus a sine of x. Now, I can either define my second derivative to go ahead and use our product rule here, because we have e to the negative x times this, so it'll be very similar to what we had up here. Or I can pull an e to the negative x all the way out. And then I have one product rule. And as I do that, I think I'm going to go ahead and do that, pulling that e to the negative x out. So that gives us c sub 1 times negative sine of x minus the cosine of x. and then plus c sub 2 of the cosine of x minus the sine of x. And what that's going to do is it's going to eliminate a lot of our product rules. So we don't have a product rule here and here. We just have one big product rule as we go into our second derivative, because we're interested in that second derivative, aren't we? So I'm giving it a little space because I think we have to mess with that y sub 1 again. So our y sub 2 is going to equal, well, it's going to be e to the negative x times the derivative of this. Well, notice we just have c sub 1, which is a constant, times this. So my derivative is going to be c sub 1. Derivative of sine is cosine. And derivative of negative cosine is going to be a positive sine of x. To that, we're going to add c sub 2. Derivative of cosine is negative sine of x. And derivative of sine is going to be negative cosine of x. So it's going to be more 1 d2. And to that, I'm going to add my 2, which is c sub 1 times the negative sine of x minus the cosine of x, plus c sub 2 cosine of x minus the sine of x, and then times the derivative of my first, which is negative e to the negative x. Now I can go ahead and simplify this, clean it up. I can multiply e to the negative x in, along with my c sub 1, into this quantity, and my e to the negative x times c sub 2 times all of this. So I get c sub 1 e to the negative x times a negative cosine of x plus a c sub 1 e to the negative x sine of x. So I'm going to add a negative, a minus sign there, so c sub 2 e to the negative x sine of x, and then a minus c sub 2 e to the negative x times the cosine of x. So what I did was, again, multiply by e to the negative x into my c sub 1 into this quantity, my e to the negative x times c sub 2 into this quantity. Now to that I'm going to add, I'm going to multiply my negative e to the negative x, again, to my c sub 1 to all of this. So a negative e to the negative x times c sub 1, and then times a negative sign, it gives me a positive sine of x. Excuse me. A negative e to the negative x times c sub 1 times a negative cosine is going to be a positive c sub 1 e to the negative x cosine of x. And again, I'm going to multiply this negative e to the negative x to my c sub 2 and my cosine and sine. So that's going to give me a negative c sub 2 e to the negative x cosine of x plus c sub 2 e to the negative x times the sine of x. And something nice is going to happen here. I should have things cancel, and I do. Notice I have a negative c sub 1 e to the negative x cosine of x and a positive c sub 1 e to the negative x cosine of x. So they're going to cancel. I have these two terms that are going to combine, so we get two of those, 2c sub 1 e to the negative x sine of x's. I'm going to go ahead and cross those out since I've used them. Here my c sub 2 e to the negative x sine of x, they're going to cancel. I have one negative, one positive. And here I have two that are negative cosines, so I get negative 2 c sub 2 e to the negative x cosine of x. And that's what y sub 2 is going to simplify to. Remember, I want to verify that y sub 2 plus 2y sub 1 plus 2y equals 0. So I can go ahead and start in on that. Let me get a piece of paper here. It's going to be rather lengthy, I think. So I'm going to start with my y sub 2. So I have 2c sub 1 e to the negative x sine of x minus 2c sub 2 e to the negative x cosine of x. To that I'm going to add, I need two y sub 1s. So two y sub 1s, that's why I left a little bit of space there. I need to multiply this by 2, and since I've already distributed it out down here in y sub 2, I'm going to go ahead and multiply this as well. So I'm going to put a 2 up there just so I remind myself what I'm doing. So I have 2 e to the negative x times c sub 1 times a negative sign of x. To that we're going to add, which is going to be a minus there because that cosine is negative. So we have a minus. We're going to multiply the 2 e to the negative x sine c sub 1 times the cosine. So we get 2 e to the negative x c sub 1 cosines of x. To that we're going to add 2 e to the negative x times c sub 2 cosines of x. So we have 2 e to the negative x c sub 2 cosine of x. And then minus a 2 e to the negative x c sub 2 sine of x. So I'm going to go ahead and bring that up. Notice I got my paper very long because I see this is going to be a very long problem. So let's see, that changes that to a minus sign. So 2 e to the negative x c sub 1 sine of x minus 2 e to the negative x c sub 1 cosine of x plus 2 e to the negative x c sub 2 cosine of x, and then minus 2 e to the negative x c sub 2 sine of x. So now as I look at this, anything that we can cancel out, clean up. So we have 2 c sub 1's e to the negative x sine of x. So notice I have a positive one here and I have a negative one here. So those are going to cancel each other out, aren't they? I have a negative 2 c sub 2 e to the negative x cosine of x, and here I have a positive 2 e to the negative x c sub 2 cosine of x. So those are going to cancel each other out. So now I have a negative 2 e to the negative x c sub 1 cosine of x minus, always that minus, minus 2 e to the negative x c sub 2 sine of x. But to that we want to add 2 of my y's, or 2 of my y's. So to that I want to add 2 c sub 1 e to the negative x cosine of x, and plus 2 c sub 2 e to the negative x sine of x. And again, we want that equal to 0. Well, if I look here, 2 e to the negative x c sub 1 cosines of x and a positive, those are going to cancel each other out, aren't they? And a negative 2 c sub 2 e to the negative x sine of x. Hey, look at that. Those cancel. And I don't think I made much of any mistake on that question, on that problem. That's amazing in itself. So a lot of work, a lot of good stuff. Work through it as you're given the solution. They're not going to be as miserable as this. This is probably the most difficult thing that you would probably see, but I wanted to show you how nasty they could get as we get into them. So you're using that solution, and you want to verify that equation. Again, look to see what we have and what we're given and what we know about the first and second derivative as we do them. Good luck, enjoy, and happy deriving.